All right, so I had this question that somebody sent me from this is section 2.1 in our book. For the homework I assigned, it's the 17th problem. I'm not sure if you're looking at the textbook exactly which one it is, but for the online homework, it's problem number 17. And there's kind of a lot going on here, so I thought maybe I could make a video talking about it just to probably help some more people that might have questions here. So let's get into it. We have this function h of x, right? And it's modeling the jump of a red kangaroo. X is the horizontal distance traveled. And when the kangaroo jumps from a higher location, it's going to land 5 feet farther away. Okay, interesting. So the thing that's maybe kind of hard about this one is that it's saying that the kangaroo is jumping from a higher location. So if we think about shifting this path up, we'd be changing this value here or adding something to the function to get a vertical translation, right? But the thing is, we don't know how much we have to shift it up yet. We just know that the landing point is going to be 5 feet farther away. So before I really get into the math part of it, let's maybe look at just something on Desmos real quick. So I have the current path of the kangaroo, right? So it starts here, jumps here, and it lands over here somewhere. And we want it to land 5 feet further away. Now, this first thing I'm going to do, this isn't really exactly what we want, but if I were to shift this landing point 5 feet to the right, okay, so 5 feet further away, I would have to subtract 5 from the x. Right, so x minus 5 minus 14 will simplify down to x minus 19. Alright, so we can see that gives us a landing point that's 5 feet further away. But there's actually a little bit of a problem with this. Here we didn't change where the height the kangaroo was jumping from. Right, so we just shifted it over 5 feet. We actually want it jumping from a bigger height instead. So we'll have to change this value here somehow. And I'll actually go ahead and show you the answer before I get into how I would find it. Right, so if we take this and we shift it up instead, we can see we're still landing 5 feet further away. But you know, it's a different kind of transformation that we're working with there. Okay, so enough about that. Let's go ahead and actually solve it. So here we go. To figure out how I would make it land 5 feet further away, I probably want to figure out where exactly it lands first of all. So the height represented by h of x, when it lands, the height above the ground is going to be 0. So I can go ahead and set that equal to 0. And let's go ahead and solve. So I'd subtract 6 from both sides, divide both sides by negative 0.03. And I'm going to be lazy with my arithmetic here and just do it with a calculator. All right, so 200. Alright, so I want to take the square root of both sides. Now you'll notice I didn't do plus or minus the square root. Normally when I'm solving like this, I would have to consider both the positive and negative square root there. But we're talking about a positive distance. In this case, I don't care for both x-intercepts, just where it lands. So anyway, I'm looking at just the positive square root here. Okay. From there then, I can say x is square root of 200 plus 14. Alright, and I don't particularly care for the decimal version of that. That would be an estimate anyway. Let's just leave it like that. If I wanted to land 5 feet further away, that would mean that my new x value here, I'd have to add 5 to. So really I want the kangaroo to land at 5 to 14. I want it to land at square root of 200, whatever that is, plus 19. Alright, so from here, we could say our new function, which actually it's still going to land at a height of 0. Alright, let's keep most of this the same. Right, so the function's staying the same. For the x value, let's substitute in what we want it to be. Still minus 14 there, so I'm keeping that part the same. I don't know how far we're shifting it up yet, so let's just say that's k. And so k then, if I add this to both sides, would be whatever this is. Let's just simplify that. That's plus 5 squared. So I'll go ahead and plug that into the calculator. And my calculator tells me it's 10.99264, so rounding any values to the nearest hundredth, second decimal place, that'll round to 10.99, which means my new function h of x is 0.3 x minus 14 squared plus 10.99.